Hello and welcome to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I am Mary Helen Armour. I am one of your hosts for this evening, and with me is Paul Mackin.
Hi there.
We are broadcasting live from the Allan Carswell Observatory located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local time Toronto, or currently 1 a.m. Tuesday Universal time. At York U Observatory. We also run in concert with our online public viewing feed, as you will see referred to on our webpage as OPV, which is operated by the observatory staff. Tonight we will be showing some archival images because it is clouding over in Toronto and there is the possibility of rain and maybe even later on thunderstorms. So we will have some of our great images that have been taken in the past on show for tonight. Okay. To navigate to our live show or learn more about us, please visit our website at yorku.ca/science/observatory and follow the link to our online public viewing. We have a chat that runs while the live viewing is going on and while the podcast is running on YouTube. And if you have any questions or comments about past shows or suggestions for future topics, you can send us an email at observe@yorku.ca. You can also always connect with us. We are on Instagram at YorkU Observatory, and there is a Facebook page at Allan I Cars Web Ob. So there's quite a number of ways to connect with us and get in touch. All of our programs are free, but we do appreciate any donations people may wish to make, which again can be done on our webpage. During the podcast, while we are live, we are monitoring the chats on YouTube, so you will get your questions answered. So we'll start this week off with our space astronomy history. And one of the topics that I've always sort of been fascinated by is, of course, life beyond our solar system. And one of the things, of course, we have done is since the late 1960s, we have actually listened to the sky with radio telescopes mainly, hoping to find a signal that has a clearly artificial or non-natural source. There have been quite a number of false alarms. Probably one of the biggest one was August 15th, 1977. So, almost 50 years ago now. And this was called the WOW signal. It was detected at the Big Ear Radio Telescope. Okay? And when they find a signal like this, what it is they find in the signal some kind of pattern that clearly comes from a non-natural source. This particular one was a little more complex, but a classic example of this, what this kind of signal might be a series of prime numbers, right? So if someone sent a signal that sort of had 1, 2, 3, 5, 7, 11, 13, etc., there's just no way you're going to produce that naturally. So there's a number of possibilities of how you could send these signals. And this was done in the sort of 1977. It is not the only signal of this type. People have been sort of searching for these kind of signals literally for decades now. It started in the 1960s, and it in the US developed into SETI, which is the Search for Extraterrestrial Intelligence. They have conducted follow-ups on this signal, and there have been other sort of false alarms over the time. But this WOW signal was never quite explained. They did not understand where it came from. They've never really identified an origin, and it's never repeated itself. So it's one of those kind of questions that's out there, like what was this source of this signal? And why was it never repeated? There have been quite a number of these over the years, but this is sort of one of the more uh, unexplained ones because many of these other ones they eventually find out oh is some sort of weird Earth satellite signal or something along those lines. This one was never quite explained. So I don't know if you've ever followed some of the SETI stuff, Paul, with all of their searches that they have done.
Oh yeah, it is a fascinating area of study. Of course, this was kind of kicked off by Frank Drake, and Drake, coined the famous Drake equation, which one day I'm going to get a tattoo. I'm convinced of. But the Drake equation basically it kind of tries to estimate the number of. It starts off with how many stars are there, and of those stars, how many have planets, and of those planets, how many are in the habitable zone, and of those in the habitable zone, how many have the conditions for life, and of the ones that have the conditions for life, how many might have evolved intelligent life, and how long does intelligent life last before it goes away for some reason? Because the eventual fate of all species is extinction, from what we know. So it calculates all these things, and then works out a probability of is there other intelligent life in the galaxy? And it always, every time the analysis has been done, the answer comes up. The probability is one. It's basically yes. There will be more than one intelligent species in the galaxy. But the question then becomes, are they close enough? Are they using radio? Do we have enough in common with them to be able to communicate?
Yeah.
So and are they trying to communicate? Right. Um, it's a fascinating area. And of course, SETI's been around for since the 50s. We've, Drake himself broadcast to space, and there have been other attempts, and we ran there's the SETI at Home project where
Yeah.
information was gathered from various point sources like stars and whatnot, and people could run a screensaver on their computer, and the computer time was used to try and look for patterns in the signal and stuff. I believe that's shut down now, but it's out there. Will we be able to find it? I'm personally of the opinion, and this is just an opinion, that it's probably more common than we think. And the reason I say that is every time we think, we've got to we have to look at the universe with a Copernican view as opposed to an Earth-centered view. And we used to think that planets were quite rare, and now we're pretty sure that almost every star has planets, and we're starting to find them in the habitable zone, and we're getting hints of ones with liquid water, and we're starting to be able to look at the atmospheres. So I think this is more a problem of distance than presence. They're
Yeah.
just very far away. But that
Yeah.
again, that's there's no evidence for what I just said other than my opinion and sort of looking at the big picture.
I mean, it's like I said, like the Kepler mission of recent years showed us just how many potential exoplanets there are out there. And Earth may be sort of an exceptional case that you had just all the right factors come together. Uh, but it's highly unlikely in a universe the size of ours that we're the only one. But it's like you said, it's a question of distance. And even listening for radio signals. I mean, your closest stars are even a few tens of light years away. That's a long way to send a signal. Um, so and assuming they send the signal even in the right direction. So
Yeah.
it's
Do they use radio? I mean,
yeah,
we used to broadcast radio signals all over, but now we use more point to point sources, fiber optics and satellites back up and down, and so there may only be a limited period where a technological civilization uses something as noisy as radio. And you're absolutely right about like exoplanets. We're up to nearly 6,000. Just I think 5,000. Looking at the number right now, I track such things. 5,983. You know, in 4,470 planetary systems. That's incredible.
Yeah. But it's like you said, though, the thing is, though, it comes back to we're so spread out, um, that finding it becomes this needle in the haystack. And that's why something like this wow signal attracted so much attention, because like, okay, maybe we've got something, it clearly appears to be, not a natural phenomenon. But what exactly is it? So it's one of those ongoing things of, and like SETI is still operating. It operates mostly on private funds at this point. They have over the years, designed vast arrays of radio telescopes, but you're still really looking for a needle in a haystack because there's just so many factors to take into account, whether it's distance, whether it's where in the radio spectrum you are, whether it's like exactly where are we pointing these things and how strong is the signal. And an artificial signal would probably be easy to pick out because it would be repetitive. It would have sort of some patterns that are clearly not a natural phenomenon, but how we even got our ears tuned in the right direction kind of thing. So,
Yeah. Again,
yeah.
what if they don't use? My big argument is, what if they don't use radio? And we're looking
Yeah.
for radio waves. But I mean, we continue to look, and my firm belief is we will eventually find it, but we may find it in ways that we were not expecting. The idea is we're looking for intelligent life. Okay, that's a noble goal, and I hope we find it. And I'd love to, I'd love to find it in my lifetime. Uh, but I think we're on the cusp of discovering microbial life everywhere.
Yeah. Oh, even potentially within our own solar system. That's the thing,
Oh,
right?
absolutely. And we'll be
So,
talking about one of the places that's a candidate for that a little later.
yeah.
Absolutely.
So,
Yeah.
so I
So,
think you were looking at some various spacecraft then, in your next sort of topic.
yeah, for me, it always, I'm, I'm an astronomer and I love astronomy, but I got a big thing for spacecraft and space science as well. So on August 18th, so today in 1985, that's 40 years ago, the Japanese Space Agency, which we call JAXA, JAXA, launched its second interplanetary exploration probe, and it was to Halley's Comet. Now, this was called, and I'm really bad at pronouncing things, but Susi. Uh, and it was part of what was called the Halley Armada. These were probes to Halley's Comet, okay? And the Armada consisted of seven spacecraft. So it started off with the Japanese spacecraft uh, Sakigate, which was really only a technology test. It carried no scientific instruments, but the idea was it was their first attempt. They launched it, and they got to about 7 million kilometers away from Halley on March 11th, 1985. The Susi spacecraft came within 151,000 kilometers of Halley, and that's a lot closer. And you're going to see a pattern here as we go through it. And that was on March 8th, 1986. Now, France at that point, I don't think was part of the European Space Agency. They were working with the USSR, the Russians, what's now the Russian Space Agency, on a probe called Vega 1 and Vega 2. And what these were is these were spacecraft that launched towards Venus. They dropped probes into the Venetian atmosphere, including balloons, which is kind of cool, high altitude balloons. And then they flew on, and the first of them, Vega 1, flew by Halley's Comet on March 6th at a distance of just a shade under 9,000 kilometers. That was on March 6th. And then on March 9th, the second probe, which had an identical profile, flew about 1,000 kilometers closer. So, and these were all leading up to something else. The European Space Agency, ESA, had a probe called Giotto, which came closest to Halley on March 14th, 1986, at just over 600, just under 600 kilometers, which is really, really, really close. And we'll talk more about Giotto in a second, but SUSI, as I said, it was their first interplanetary mission, carried two instruments: an ultraviolet imager and an electrostatic analyzer for studying solar wind and plasma. But its real purpose, you know, beyond getting Giotto as close as possible, they were all basically providing information to the European Space Agency to allow them to zoom in, was to get the real purpose was to get JAXA on the map in terms of deep space missions. And it succeeded because JAXA is now in the top four space agencies after NASA, the ESA, and the Chinese National Space Agency. Sadly, the Russian Soviet program, they don't really do a lot of exploratory missions now that I can find. They're really focused on, the Soyuz support for the International Space Station. But the Halley Armada was a real example of international cooperation. Sadly, it didn't include U.S. participation. They had a mission that was quite ambitious, actually, but it was canceled in 1979. And we'll talk a little bit more about that too today. But Giotto did produce some spectacular results, which showed Halley to have a peanut-shaped nucleus, and found that the material ejected from the comet was coming out at a rate of 3 metric tons per second. So that's 3,000 kilograms per second. And it was 80% water, 10% carbon monoxide, and 2.5% a mix of ammonia and methane. And the remainder was hydrocarbons and trace elements. But this mission went on. Giotto was put to sleep for a little while after that, and then woke up to fly by another comet. It couldn't get pictures of the second comet because it got so close to Halley that its camera was damaged during it. The camera's vision was obstructed by damage to it, and it wasn't able to get missions. But I actually remember this was a big deal at the time, and the public really glommed onto it because Halley comes every 76 years, but this was not the last one was not a very good flyby from an Earth, close approach to the sun from an Earth visibility point of view. I did actually see it. There were observing nights in Toronto, but it was a reach. It was a real
It was,
stretch to get it. Yeah,
yeah,
it was hard to find.
it was a hard to find one. I was just old enough to remember, and I remember being up at our cottage. We had the binoculars and the small telescope and trying to figure out where it was in the sky, and you could not find it. It was just too difficult to try and spot. It was a real disappointment because if you went back to the Halley's Comet of like the early 1900s, it got so close to Earth, Earth actually passed through its tail. And there was a certain amount of hysteria at the time, like end of the world comet parties because they were afraid, the end is near kind of thing. And they detected cyanide in the tail of the comet. So, people were quite quite, I guess, worried about this. And, there's a certain amount of panic at the time. And then 1986 rolls around, and it was a disappointment. What the next one will be like in, what is it, 2060? Something?
2062. And that date is the best reason I know of to live to be 102 years old.
So it's like I said, maybe the one in 62 will be a lot more spectacular because the one in 86 was a fizzle. It was disappointing. But it's like I said, you did see the Giotto pictures later, and there's still some of like the best close-up pictures of a comet that we've ever gotten. I mean, they put
Yeah,
a lot of effort into that, starting with the JAXA missions. But it's like you said, they managed to do it. And now you're going back in technology, like late 70s, early 80s technology. So, 40 to 50 years ago, and you think about it, we've come a long way.
We have, and of course, the European Space Agency also had their Rosetta mission
Yeah,
to a comet that even landed on the comet.
yeah.
So yeah, we have come a huge way, and there are more comet missions planned. But Halley's kind of got this special story about it. You know, to every second generation sort of gets Halley. And what was it? I think Samuel Clemens uh, was born the year Halley came and predicted his own death the year Halley came. He said, "I came in with the comet, I'll go out with the comet," and that's exactly what happened. But so it's it's not very different from the span of a human life, 76 years. So
Yeah, so people do have the possibility of being able to see it twice, but it's going to be rare. I mean, that was the funny thing is Edmund Halley, when he first predicted his return, took a lot of flack because he predicted his return. They figured long after he'd be dead, so he took a lot of flack over that. But the physics was what the physics was. But it's like I said, you trace it back. We've had sightings of Halley's comets, like we've got records of it going back like to around the time of William the Conqueror. So it's one of those things that's like in the human, I don't know, psyche isn't quite right, but it's sort of that background, urban legend, mythology that it's always been there through human history. So
it's kind of amazing because in the day, Halley's time, comets were predictors of doom, and what he did ultimately was show that no, they, they were predictors of celestial mechanics. So it's it's a fascinating story though. But speaking of people predicting things though, I think you've got a story from much earlier.
yeah, so I was sort of flipping around, and I've always been sort of a bit into the history of astronomy. So like you look at eclipses, and on August 21st, 1560, there was a full eclipse. It actually started in North America, traveled across the Atlantic, and then sort of went through southern Europe, but at least partially it was visible through all of Europe. And this was one of the first eclipses where they really started having some, I guess, more scientific type observations, because this was really the era when you started getting sort of more serious um, science approaches to astronomy. And interestingly enough, sort of the last great observer before telescopes came along was Tycho Brahe, and he was known to have observed it. It would have only been a partial eclipse where he was in Denmark, but he certainly saw it, and this was one of the things that seriously generated his interest in astronomy. It's quite interesting because this accounts of this eclipse also appear in a number of places in sort of literature in Europe at this time. It's sort of one of the ones that starts being well recorded and well historically documented. And not just in Europe, of course. If you go to South America, the Maya were expert mathematicians, and one of the things they had figured out was the eclipse cycle. Now, that didn't mean they knew exactly when an eclipse would happen, but from their mathematics, they knew when eclipses were possible, and when a solar eclipse or a lunar eclipse was likely to occur. Um, so they had certainly predicted this one of 1560, like that's in the records. And of course, by this time, you started having people, uh, you know, uh, European adventurers, exploring, conquering this part of the world. So, like they had known there was potentially an eclipse at this point. Like this one was kind of an interesting one because it really, I think, came in on the European consciousness in a way before that, they were just kind of random, scary events. And yet by this time, they were starting to understand that you could predict these things, that they were regular, even if they didn't quite have it figured out in Europe. Certainly the Mayan had figured it out hundreds of years earlier how to predict these kinds of events. So it was quite interesting. I mean, and this is the part where they start to sort of record and take pictures and look at images. There was another eclipse around the same time, of course, in 2017 around this week. Some of the eclipses around, this week in the early part of the 20th century, this was another one where at that point they were looking at eclipses to try and prove or disprove some elements of Einstein's theory of general relativity. Because if you look at an eclipse closely enough, you can potentially see how the starlight is being bent around the sun. So you would see stars beside the sun that are actually behind it because of this bending of light. So a couple of the eclipses early in the 20th century, this was also something they were looking at. And a couple of them were sort of August eclipses that they were chasing around the world to try and sort of establish the accuracy of Einstein's theory. So that's another way in which sort of eclipses have become sort of scientifically valuable because they were part of how they did prove general relativity. But 1560 is kind of the interesting one because from a science viewpoint, this is really when you start to see eclipses going being from these sort of random, scary, crazy, like end of the world doom and gloom kind of events to something rare but explainable and looking at sort of what are the other potential ways in which we can use this, because you can also, of course, use eclipses and transits like that to help to try and figure out the distances between Earth and Sun and a number of other factors when you sort of apply the geometry, when you understand the setup of the solar system. So
Yeah, it's fascinating.
interesting one.
I've actually been to Brahe's observatory in Copenhagen. What that man accomplished with just his eyesight, because there were no telescopes, was incredible. I'm gonna give our listeners a surefire win next time they're playing trivia. You mentioned using eclipses to basically confirm elements of general relativity. So general relativity has proven to be very robust, and it's actually a great subject to study. But and Einstein won a Nobel Prize, but Einstein didn't win a Nobel Prize for relativity. He won it for the photoelectric effect. And so next time you're in trivia and someone says, "What did Einstein win his Nobel Prize for?" Photoelectric effect. It was not relativity.
Yeah,
So
at the time relativity was so radical that the Nobel Prize Committee just wasn't willing to give it to him. And yet the photoelectric effect was much more observable, much more sort of fit in with other understanding. And it's the basis of all of the solar panels we now use, right? And some of the work that came out of that, of course, was also what went on to be the basis for how lasers worked. So Einstein had his fingers in a lot of different areas of physics. We remember him for general relativity, but he did a lot else as well. So
and he did it all in a very short period of time. I mean, he had
yeah,
that sort of 1 or 2 year period where he basically rewrote physics.
yeah.
Uh, and uh, and every once in a while you hear, well, Einstein's been proven wrong, or scientists say this. Einstein has been very robust.
I mean, yeah, there are some aspects of things that he was wrong about, his cosmological constant and a number of other things, but nobody's right all the time.
Nobody's right all the time.
But the
And when
basis
you're
of what he's done, the basic outline that he placed was really, really robust.
and when you're redefining science, a few things will slip off the edge of the plate. But we do have one more space story for our in history, and this one's exactly 50 years ago on Wednesday, on August 20th. The Viking 1 spacecraft was launched towards Mars. Now, after Apollo, the Viking and Voyager missions were the last big budget interplanetary efforts on NASA's part for quite a long time. A space shuttle was consuming prodigious amounts of cash, and NASA had really shifted their focus from the moon and solar system exploration to low Earth orbit and human space operations, much like the Russians have done now. Now, their motivations were somewhat different, but that was a shift that NASA did make, and then has shifted back in some ways. But Viking was kind of an amazing mission. It was a two-part spacecraft with a large orbiter and an attached lander. Two of them were launched. The mission profiles for both spacecraft were similar. They had an 11-month cruise to Mars, and then the Viking 1 went into orbit on June 19th, and they already had an idea of where they wanted to land the lander, but Viking's job was to take pictures of Mars, and more specifically, detailed pictures of the landing site, and then when received instructions from Earth that the landing site was good to go, then it would release the lander. But they originally wanted to have the lander touch down on July 4th, 1976, which was the U.S.'s the anniversary 200th anniversary of the Declaration of Independence. But they found that the original landing site was too rocky, so they delayed it, and it touched down instead on July 20th, which was 7 years to the day after the first manned lunar landing. So Viking used, a pretty now standard mechanism for landing smaller landers on Mars. It used a heat shield to slow itself down in the Martian atmosphere, followed by a parachute, and then rockets from about 1.5 kilometers up to take it down to the surface. It landed at, and here goes my getting terrible names again, Kairis Planitia, which is the Golden Plane, and immediately began and began taking pictures immediately. And this was the first successful landing on Mars. The lander, which was eventually named the Thomas Much Memorial Station, after the head of the imaging team at NASA, operated for 2,306 days until November 11th, 1982, when a faulty command accidentally resulted in loss of contact with Earth. It also carried a biology experiment. This is one of my favorite stories, whose purpose was to look for evidence of life. The lander biological experiments weighed about 15 kilograms, 34 pounds, and it consisted of three subsystems: the pyrolytic release experiment, the labeled release experiment, and the gas exchange experiment. And it also carried a gas chromograph mass spectrometer that could measure the composition and abundance of organic compounds in the Martian soil. The results were surprising. The spectrometer gave a negative result. The PR gave the pyrolytic release gave a positive result. The PR gave a negative result. The gas exchange experiment gave a negative result, but the labeled release gave a positive result. Now, most scientists believe that the data was due to inorganic chemical reactions in the soil, but some people are skeptical about that because they did discover near surface ice in the Viking lander zone. Mars has almost no ozone layer, and unlike Earth, ultraviolet light sterilizes the surface, which produces highly reactive chemicals such as peroxides, which would oxidize any organic chemicals. But those same peroxides could give the positive result that was seen in that experiment. So the jury is still out on this. There will be other spacecraft that will attempt to do it. And of course, we do have sort of plans out there, maybe kind of, to get samples back to Earth. The Chinese certainly plan to, and America's collecting samples. Whether they get them back to Earth or not is a matter of budget.
Yeah. And sample returns are challenging because to sort of take your whole rig there and then put it down where you can blast off of the surface, and blasting off the surface of Mars is going to be more complex than getting off the surface of the moon, because of course your gravitational strength is about twice, and you do also have an atmosphere. So it's, there's going to be some challenges involved. But it's like I said, I've done a fair bit of reading about the Viking experiments, and the funny thing is originally actually all three came back positive, but they realized two of them were false positives, and it was surface chemistry that was messing them up. And it's like you said, the final one, they still consider it positive, but they don't know why. And people are like, well, why didn't you design a better experiment? Well, the experiments they designed were actually based on what you would find in like Antarctic soil. And under those conditions, yes, they would work. What they didn't take into account, because they didn't really know at the time, was what the chemistry of the Martian soil was actually like. So the experiments were an interesting attempt, but they just, because they didn't know what the soil on Mars was, these were the first real landers. The experiments just weren't designed properly, right? They just couldn't get the results that they were looking for. But it was a fascinating attempt, right? They put a lot of
Absolutely.
thought into it. They put a
Yeah,
lot of thought
absolutely.
into it, but they kind of missed it altogether.
But again,
Really.
this was a first attempt.
Yeah.
You
I
don't
mean,
ex you know they were to some degree guessing.
oh yeah. I mean, they did the best they could. I mean, they tried it in like arid and dry regions like the Antarctic and stuff where they figured it would be, um, pretty effective. But it just, there were factors that they just couldn't take into account. But that's the nature of science. It always goes on like that. So we've reached about the high halfway point. So just a reminder, you are listening to York Universe. We are broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Canada. Please take a look at our website at yorku.ca/science/observatory. If you go to the YouTube link, you can join our chat. And if you have any questions or want to see some of our content, you can certainly ask them there. Tonight you are listening to Paul Mackin and myself, Mary Helen Armour. We've been discussing some historical items. Unfortunately, tonight, because of the weather, our team only has some of the archived images that we've taken in the past because unfortunately we can't open the dome. But again, I hope you are enjoying the images. Just also a couple of news reminders. As with most weeks, we will have tours on campus at York. This Wednesday, we will have an observatory tour, so it is up in the domes, where you can sort of see the telescopes and get a tour and everything of how they operate. Uh, Weather dependent, we will open the domes and do some live observing while people are there. But again, that depends on the sky conditions because we can't open them if there's too much cloud or there's any kind of rain and precipitation. For our Wednesday night tours, they are always free. But again, we always welcome donations, or if you go to our observatory website, we also have some great astronomy swag you can buy, which helps support the observatory. Uh, so again, now we'll move on to some news items. And I have been watching this summer because in the past I have missed a couple of great events. And I have been watching the NOAA website, which is the National Oceanographic and Atmospheric Group down in the US, and they have a great aurora predictor page. If you just put in NOAA and then aurora in a search, it will come up. And what it does is it shows you when the northern lights might occur. Now, they generally can only predict out about 48 hours, a couple of days, maybe a little longer. Right now, although the skies are not cooperating because it looks like it's clouding over in the Toronto area, there is a possibility of being able to see some aurora. Uh, the sun goes through cycles. It's reached its peak a little bit in the last month or so, and now the number of spots will start to decrease, but we still are in sort of a period of high solar activity and potentially still for the next couple of years. We are at sort of a high uh, possibility of these solar storms that will produce the northern lights. The storm that they have observed, in the last 24 hours is a relatively minor one, but it will still be enough, especially if you're in dark sky areas, to produce an aurora. So it's a great page to watch because otherwise Northern Lights are not like many other astronomical phenomena like the orbit of a planet or when stars rise and set. We can't really predict them much more than about 48, maybe 72 hours out. We know the sun's in a period of high activity, so it's much more likely to happen, but it's one of the tougher things to predict in astronomy. I mean, even things like eclipses and stuff, we can tell for years beforehand. We can calculate out years where they are going to be. Things like the Perseid meteor shower, again, is quite predictable. Northern Lights, not so much. But they do often produce some spectacular colors in the sky. The last couple of years, we've had a few great episodes. I don't know, Paul, have you gotten any pictures of some of these Northern Lights events over the last couple of years?
Yeah, last year I went up just north of me. It was funny. Uh, there's a lake, Lake Simcoe, and the south shore of it. You've still got a lot of light pollution there. I think you're the opposite side of that lake, Mary
Yeah.
Helen. But yeah, but I went up there. It was took my camera, and it was interesting because when you got there, there was a lot of people because they'd all heard on the news and stuff, and they didn't really know what to expect. And it was interesting because the human eye is not that great an optical instrument, but cameras can be. So I had my camera set up, I had my iPhone in my hand, and you could sort of see something going on in the sky. But boy, when you open that shutter for a second or two,
Oh yeah,
wow, it was
it was
incredible.
spectacular. I
Yeah,
mean,
it
and that's
really
the thing.
was.
People don't realize there's a lot of these pictures you see on TV and the news and everything. The camera's really great at picking it up. I had the same thing, probably the same one last summer. I'm standing out in my backyard. I'm like, I can see a little bit of color out there. And then you put up the iPhone and you take the picture, and I'm like, oh, okay.
Yeah.
That's right. You can see a
Well,
lot better on the phone. I mean, we're still fairly far south for them, um,
we
even
are.
when you have a fairly strong solar storm. But I've never been up that far north, but I know people have been, and they say if you are up there and you get a solar storm, you don't need the camera. It actually looks like those sort of glowing streams of light, and it is quite spectacular. It'd take a
Twi-
pretty
yeah,
spectacular event, yeah, down here to see that.
I lived in the Canadian Arctic for a number of years,
Yeah.
and I remember one night I was in Hay River and I was working for the power company up there, and I was walking back to my apartment after after we were celebrating finishing a project, and we were all feeling pretty good about it. We had a nice meal and a few drinks and whatnot, and we're walking back. And I remember just as I got past the edge of town, my apartment was slightly outside of town, and just up there things are pretty close together. And I remember looking up, just getting past the lights, and it was just sheet after sheet of white rolling lights. It was unbelievable.
Yeah.
And I also lived in Norway. Someone who likes warm weather as much as I do. I seem to spend a long time in the north, but and there I saw pink. Whereas the ones we saw last year, I think, were kind of more the green, blues, purples.
Yeah.
But yeah, it's remarkable, just
Yeah.
remarkable.
I mean, I always wonder, I mean, obviously I vaguely remember being a kid up at our cottage in the 80s when they had some of those big ones that knocked out the Hydro-Quebec. And I vaguely remember seeing them in the sky of this like, just shimmering lights. It's like, what the heck is that? But you kind of wonder during the Carrington event, how spectacular must the Northern Lights have been if there was enough energy to sort of run telegraph systems with no power connected and some of the other phenomena. Like the Northern Lights during those events must have been absolutely spectacular. And yet it's before the day of real photography, um, or instant photography the way we have. So there's just not much for records of it. And yet it had to be spectacular during that.
Right. So for your trivia night again, we have Northern Lights, Aurora Borealis. There are Southern Lights as well. What are they called?
Aurora Australis.
That is absolutely correct. And I have not seen those. I've been to Australia
Yeah.
quite a few times. but I've never seen those.
Yeah, they're not as
So
spectacular down south just because of the orientation of Earth's magnetic field. You don't tend to get them at the South Pole nearly as strongly as you do at the North Pole. So
yeah, yeah, on my bucket list, I suppose.
I think you have to be in the Antarctic on just the right day to see them well.
The Antarctic is actually someplace I've always wanted to go. So maybe one day.
Yeah.
Yeah. So, speaking of pretty lights, um, Saturn has this moon, and it's called Enceladus, and
But
it's not a very big moon. It's it's
it's
it's
bigger
it's
than a lot of Saturn's moons, though.
it is it is. So some of
Relatively, it's quite large
yeah. Well, like Saturn's got like 200 moons. So,
and
but
counting.
and counting. Every time they look, they find more. Well, you could argue, I suppose, that Saturn's got an infinite number of moons because each of the rings is made up of particles,
Oh yeah.
which so they're all kind of technically moons, but they're very small. But it's got this one moon that is tidally affected by Saturn, I think probably by Titan, and it gets stretched and pushed, and it's got a liquid ocean much like Europa does, and Titan probably does under the surface, frozen, and there's a layer of ice on top. But the layer of ice is being stretched, so you get this effect where geysers of water burst out, and the Cassini spacecraft, when it discovered, which was how these were discovered, they decided to fly the Cassini spacecraft through it. Some of its instruments would have been able to do a rather limited analysis on the material, and it was water, because it is water ice, and it's a water ocean with salts probably. Um, but recently, there at the University of Idaho, a scientist called Matthew Hedman um, was talking about the fact that this study has started to look for evidence of rainbows in the Cassini images. And the Cassini images were monochrome, so you couldn't see any color. But what they did was they started to look at 450,000 images, and this is where data mining is so important in what we do in astronomy: data management and data mining. And they started to look at these images, and they saw patterns which could be indicative of, I love this word, space rainbows. I mean, that is just the coolest idea ever. So they haven't really seen the colors, but they have attributed the patterns they see to something that if you were there and took color images, you might see rainbows. Now, again, a couple of qualifiers. The level of sunlight out at Saturn is really not the same as at Earth, not even close. Um, it's, I don't know, one maybe 1/64th as bright, maybe 1/128th, something like that. It's pretty far out. But so you're dealing with dark conditions. You're dealing with very tenuous flows of water crystals. But yes, there should be some space rainbows there. And I love this story because it touches the romantic part of my soul. You're out there, you're the first human spacecraft out to Saturn, and you see a rainbow, and it's just how cool is that? So
I know, and part of me thinks like talking about Northern Lights, if you go out there, Saturn has Northern Lights as well. They have quite spectacular aurora,
they
and they've been
do.
photographed. So it's more of these lights in the sky kind of thing that you get, and it's not limited to Earth. I mean, I think that's the interesting thing is we think about rainbows and we think about aurora and we think about shooting stars and everything, but you're going to see them on all the other planets too, right? You kind of wonder if when humans eventually move to Mars, uh, Mars doesn't have really any magnetic field, so you wouldn't get northern lights. But would you still see meteorites? Because of course, right now the Perseid shower, we're past the peak, but you're still going to see a fair number of them. You wonder if Mars
Mhm.
would have. You wonder if Mars would have meteor showers. Is there a thick enough atmosphere? to really produce that effect in the Martian atmosphere, right?
Yeah.
So it's like I said, we see sort of all these lights in the sky, but it's kind of it's interesting to wonder how they would compare on other planets because we know it's like I said, you're seeing rainbows, you're seeing northern lights in some places. What else would we see? Sort of lights in the sky. How would we observe? Obviously the constellations and stuff wouldn't really change, but how would these be observed from the surface of another planet? Right? It would be very interesting to know.
And Saturn sort of got it all, doesn't it? I mean, because you've got these geysers, right? On Enceladus, you've got the rings, which are spectacular. Now, Saturn, of course, is not the only planet with rings. All of the outer planets have rings, but Saturn's got them on an epic scale. And then you go to Titan, which has an atmosphere, but it also has, and I'll put this in quotation marks, rain
Yeah.
and maybe snow. No, it's now it's not liquid water. It's liquid ethane and methane, but it's got those effects. So, and it's got an atmosphere. I mean, I've often wondered what would Saturn look like from the surface of Titan. And you know what? We're gonna find out because we got a spacecraft launching in, I think it's currently scheduled for 2028, called the Dragonfly mission, and we should actually do an
Oh yeah.
entire show on the
Oh
Dragonfly
yeah, you
mission.
could.
Yeah, but they're sending basically a drone to fly through the atmosphere of Titan, and it will be able to do things to look up at the sky and see if it can see Saturn in the sky and things like that. So, I mean, in addition to how wonderful space and astronomy is from a science point of view, it's just beautiful. It's just beautiful.
Oh yeah, I mean it'd be fascinating to see sort of all of these different views around the solar system. And we tend to think of them in terms of looking from Earth or looking from spacecraft. But what would it look like? I mean, the only comparison we have is standing on the moon and looking up at the sky or looking back on Earth. And that's still pretty close to what we see on Earth. What would we like to stand in the atmosphere of Mars and actually look up? I know some guys at York have actually created little movies and there's been a lot of simulations of what the Martian sky looks like and how the clouds move and all that. But to actually do it, I think would be absolutely fascinating.
Yeah, I agree. It would be absolutely. So, but I think you've also got an Earth phenomena, which is earthquakes, and but
Yeah,
Earth is not alone in getting
Earth is
shaky
not
ground.
alone. The next object after that we studied geologically for these kind of things, of course, was the moon. Apollo 11 did plant seismometers on the moon, and we monitored them for quite a while after that. I don't know if they're still doing that. I'm not sure. I don't think it's still functional. But they did observe an awful lot of earthquakes. Uh, Now our space probes are good enough that we can look at the lunar geology and tell where there have been effects like landslides or moving material likely to have been the result of earthquakes. Most of the quakes we have monitored on the moon are very, very weak, like tiny compared to what you see on Earth. But there is the potential for bigger earthquakes. And now, as they start to look at the possibility of building a lunar base, this business of lunar quakes starts popping up as, hey, wait a minute, we've really got to watch for this. Um, and they've been using images from various missions like the Lunar Reconnaissance Lunar Reconnaissance Orbiter (LRO) to try and see if they can see evidence of where more significant quakes have hit. Because right now, it's just the seismometers that were planted by the Apollo missions, and that's early 70s technology planted on another planet. So it's certainly found the quakes, but only like you're only in a very limited number of locations. And it is a consideration because, of course, on the moon, one of the most likely places to build is sort of underground where you're out of reach of any kind of solar activity. So the possibility of earthquakes when you're living in a cave is probably one you really want to have a good handle on to know what like what you might be up against and how you may need to build your structures to account for these. Now, it's like I said, I don't think you're going to get earthquakes on the moon like we had in Kuril, Russia a week or so ago, which was a massive earthquake that triggered some small tsunamis. But it doesn't have to be nearly that strong in order to be a hazard if you're digging in under the lunar surface to create habitation. So that is something they're going to have to take account to. And there have been a couple of interesting articles about these lunar quakes and how they're looking for them and how they're trying to take this into account, right?
Yeah,
So
and it's interesting because the NASA has announced that they're looking to deploy a nuclear reactor on the moon in 2030. Now, you know, we could talk about the wisdom of that or the feasibility of that. Those are different matters, but that is now sort of an idea they're playing with. And if you've got moonquakes, you're going to have to engineer for that.
yeah, and
But then again, we build nuclear reactors on Earth and we have earthquakes. So,
yeah, it's a phenomenon you can deal with. I mean, just the whole nuclear reactor on the moon thing, I kind of shook my head. There's so much solar energy there. One, why would you need it? Even if obviously you have a lot of days without sunlight, but at the same time, um, it would be easier to build batteries and store the power. And there are other potential sources of power that we don't have to go down this route of
yeah,
nuclear reactors. It's I don't know. But I understand why you play with concepts like that, right? Could it be
you do.
possible if we had to need and the need is there to at least think about it and speculated about it. Because otherwise, if suddenly you realize you need it and you haven't sort of thought about it ahead of time, it's a much trickier proposition to deal with.
Yeah, and there is definitely a role for nuclear reactors in space exploration. Just don't know that 2030 and the moon is the most suitable or realistic.
Yeah, I think that's a bit of a pie in the sky.
Yeah,
It's one of those like concept ideas of could we do it? So that we have some
yeah.
preliminary ideas out there.
But I mean, we're going to be. You talked about the seismometers. They're not working. I just checked. They're not working. Apollo 11 had a seismometer, but it only operated for a few days because it was solar powered. But from Apollo 12 on, they deployed seismometers, and those had an RTG, a small nuclear battery, and they operated for a couple of years. And
Yeah.
one of the things that they used to do was crash the upper stages of subsequent Apollo rockets into the moon to detect them, and of course the lunar landers,
Yeah.
the upper stage of the lunar landers. So Apollo 10's upper stage went into heliocentric orbit. Apollo 11's went into a lunar orbit, might or might not be there, but all the subsequent ones, except for Apollo 13, of course, they basically were crashed into the moon, and the seismometers actually detected the
Oh yeah.
quakes.
Yeah, it doesn't seismometers are sensitive enough. You don't need a whole lot, right? York used to have a seismometer in the Petrie building, in the basement of the Petrie building, and every time like a bus drove too close, you could see the shaking. They're quite sensitive. So
Yeah, they are. Yeah.
yeah.
So
I see though,
it's
I
yeah,
think we're at time though now.
we are.
At some point the discussion has to come to an end. So I see we're at time. You have been listening to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Paul Mackin and myself, Mary Helen Armour. This podcast and past episodes are available wherever podcasts are distributed. You can also always connect with us on Instagram with the handle at York U Observatory or on Facebook at Allan I Cars Web Ob. If you take a look at the podcast on YouTube, it has the accompanying video of our astronomy images for the evening. Okay. Our website is yorku.ca/science/observatory. And there we have lots of interesting content, including links to images, links to our YouTube page for all our past podcast episodes. And of course, It is where also we can accept donations, which are tax deductible to help us keep and ex keep running and expanding a lot of this public outreach that we do. So again, thanks for tuning in this evening. I'd say clear skies, but I think we're going to have rain later, so find somewhere dry, and hopefully you still get some clear nights to see the Perseids over the next week or so while we have close to the new moon. So good night, and thank you for listening.
Good night, everyone.